you all for being here. My name is Šarić. I'll talk a little bit more about me in the following slides. Right now, I will present the agenda. The title of today's talk is Secure by Default Spring Apps, Zero Trust, OAuth2, and Runtime Policies. Okay, so today's presentation agenda. We will first talk about our problem statement, which I have titled The Illusion of the Intranet, referring here to the outdated notion of security achieved by relying on a secure perimeter, which developers would access over a VPN, for example, and having total trust of all services and actors inside the intranet, because we are protected from the big bad public internet. Another variation on this problem talks about bearer tokens and intercept replay attacks that result from intercepting such tokens. This will be our introduction. Well, this will follow then with the introduction to Zero Trust architecture, how we can implement this with OAuth2 in Spring. We'll also talk about runtime policies. The example used here is OPA as a runtime policy engine and language. At the end, we'll talk about a checklist, how we can migrate our existing system to be secure by default, to follow the latest security recommendations. And we'll have a short Q&A conclusion at the end. So a little bit about me. My name is Šarić. I come from Croatia. I'm living and working in Spain. I'm a senior software engineer, one at Path Variable, which is an LLC registered in Croatia that is currently dormant and that I have used for freelancing work before. Right now, I use it to do research. I'm also a senior software engineer, backend specialization at Revolut. I have currently started working in the trading department. Previously, I've worked in the financial crime department and a little bit in the Latin American expansion department. Here are some QR codes I think should work. That should link to my GitHub profile and LinkedIn profile if you'd like to know more. I have done some open source work. One contribution I always like to highlight, which I am very lucky to be able to have made, would be to the SPIFFE library for the Croatian language lemmatization. I think it was around 2017. A recent contribution would be a few pull requests to the Apache Commons Lang library, 2526. Christmas holidays, what can you do? You can code open source. I also write some of my own Bash and Golang tools for interacting with home security cameras. Mostly it revolves around the ONVIF standard, which is a very nice thing that security cameras have, IP security cameras. They expose a set of interfaces so we can listen to things like motion events, use the intercom system, get the RTSP stream, for example. That's very nice. And it's a standard which, if a camera implements, you know you have at least some of these minimal capabilities baked in, with potentially others. I've also done some open source work on home and garden automation since around 2021. I wrote a small project for this. It was awarded some funds from the state, and I presented it a couple of times. Last time I presented it at Open South Code in Malaga last year. Yep, my experience with the Spring framework, for which I am grateful. I think every Java backend developer is grateful for Spring. So the first 5 years of my career were spent working with Spring and a proprietary framework by SAP, which was then called Hybris, and it was about e-commerce, building backends for web shops. And they used the Spring framework and built their own framework on top of it, and it provided a lot of additional templates and code design patterns, which were very useful in this environment, and some basic domain modeling, which again was very useful, especially if you're an inexperienced developer in the e-commerce domain. I've also used Spring in telecommunications backends, accounting backends, and I have some of my open source experiments on GitHub using Spring. Here we have in parentheses OpenCV and graphs. So it was some camera video capture, an attempt to stream video through a Java backend. I still think real-time video streaming with a Java backend is difficult, and someone could make a great open source project by making a library that makes it easier to make some kind of camera dashboard with a Java backend. Golang has excellent support here, for example. Yeah, so that's a little bit about my experience with Spring and what motivated me to apply for this conference. So let's focus on our problem statement, the illusion of the intranet. So the legacy approach to security, and I'm talking here, just to clarify, about large corporations which maintain a large collection of services, microservices. They are often geographically distributed across multiple continents. They can have tens of thousands of employees, some of them technically adept, some not so technically adept. And this legacy approach had obvious vulnerabilities, which was if you were able to gain access to a single component in the network, in the intranet, you could effectively run amok through the whole set of services that the company had. So the new approach is cloud-native zero trust. And what does this mean? Instead of one big perimeter, zero trust establishes localized security boundaries that isolate threats right where the work is happening at the workload level. This means each service must be explicitly granted permission to interact with the service for one, and the other thing, tokens identifying users must also be specified as belonging to a specific service, and that we need to be able to verify that independently. So this is accomplished through mechanisms like mutual TLS, dynamic policies, which also enable us to include business rules in our security checks. This would include things like business hours, or we could test out a specific policy that we think might mitigate risk in certain circumstances. Business logic means when I'm checking if a user is authorized to access a resource, I can check additional things like the geographic location, the date and time, the user's department, okay, that's standard, but other intangibles, I could query external services if needed. So the other problem here we have is the use of bearer tokens, which are a very cheap way of authenticating. They are vulnerable to intercept, meaning if an attacker has gained access to the intranet and can intercept a token, they can make a replay attack on a different resource. So the specific and most troubling scenario here is, imagine a user with a very high level of access. They have used a less secure application in the intranet. Their token is intercepted. Without additional protection, you could use this token to perform a replay attack against a service which has more valuable or vulnerable data. And this, of course, is a big issue. Again, reminding you here that the environment in which these threats are most viable and most potent is the environment of the large corporation spanning multiple geographical locations, potentially multiple continents, and with employee numbers in the multiples of the thousands. So the answer to this, the modern security paradigm, the secure by default architecture, rests on three pillars. One is identity, which Spring can offer here, the Spring Auth server. The other one is workload trust, meaning here, so we use the SPIFFE approach here to establish mTLS and to rotate SSL certificates. And the third pillar is runtime policy definition. The example used here is the open policy agent, which has specific advantages. It runs in a sidecar. The Spring application will query the sidecar to check for permissions, meaning that a change in the policy does not require a restart of the node running the application. And also, given the format that the policy is written in, it can rest in a Git repository, and you can have a CI/CD pipeline to do verification of any changes in the policy. So talking about pillar one, let's look at the two approaches to tokens, the self-contained JWT and the opaque reference token. So JWTs are a way to authenticate. It is cheap in terms of performance because it is not externally validated. And again, as mentioned, without additional protection, it is vulnerable to replay attacks. Opaque reference token would be a token issued by the server, which requires constant verification from the authentication server. In this way, you can revoke the token very easily from a central location. However, it has a performance cost because for each request that a party makes, the receiving party needs to verify that token with the authentication server. A rough illustration of the performance trade-off here and of other aspects. So again, main issues here would be, one, can we revoke the token from a centralized location easily? The other, what is the cost of verifying it every single time for every request? Given these limitations, you would most likely not want to use the opaque reference token on the actual front end where users interact with the services from the public internet, unless you are really unsure. But there are other ways that you can boost security of the JWT. So, pillar two, who is actually calling your API? We are talking here about workload identities. I'm going to introduce a few concepts here, which would be SPIFFE and SPIRE. So, in our new modern system, a SPIRE server will serve as the central certificate authority, which will, through SPIRE agents, perform the node attestation in clustered environments like Kubernetes, and will provide an SVID, which is a SPIFFE variable identity document, to the workload. The term workload here refers to any service or application running in the intranet. So the exact implications here are, you are provided with certificates to establish the mTLS. Those certificates are rotated at regular intervals. Each service will receive their fresh certificate. And what's more, each service can specify in its configuration which services it accepts messages from. An additional feature here is, because we are certain we always have certificates to perform mTLS, we are then enabled to boost the security of our JWT by adding the certificate thumbprint to the list of claims of the JWT. What does this mean? The party that is granted the token includes its certificate thumbprint in the list of claims when submitting the request for the token. The party which receives the token will extract the thumbprint, compare it to the public key, well, it's a SHA-256 hash of the requesting party's SSL certificate, compare it to the actual thumbprint, so the claim to the thumbprint, and if these do not match, it will reject the token, regardless of whether or not the other claims or signatures are valid. This is a way to prevent replay attacks, because even if a party intercepts the token, so we have already breached inside the intranet, we have intercepted the token, we still cannot execute our attack on a different resource because the thumbprint will not match. We do not possess the mTLS certificate, and the certificates are rotated automatically and regularly to boost security. what I have been saying right now. So, SPIRE, an implementation of SPIFFE, will provide us with short-lived certificates. Automated renewal. The SPIRE agent is a sidecar. Again, another sidecar running along each Kubernetes node, and in coordination with the SPIRE server, it does the actual certificate rotation and exposes it to your service. This means the service is not shut down, it continues to run, and it gets the certificates from the sidecar. This is what I was referring to. When we have these mTLS, we can follow RFC 8705, certificate-bound access tokens. It's the mechanism to enhance the security of access tokens by binding them to a specific client certificate. This is designed to prevent replay attacks, where an attacker intercepts the bearer token and uses it to gain unauthorized access. DPOP, which is another RFC from the IETF, number 9449, would be a sort of front-end counterpart here. Since using mTLS from the back-end would be difficult for the front-end client, we can have the front-end client generate its own mTLS certificate pair and register it with the authentication server. So this is distributed proof of possession, and again, another protection against replay attacks. The client is responsible for generating the certificate, so this adds a little CPU overhead on the client side. However, it's still cheaper than using an opaque reference token, so it's worth considering as a front-end solution in environments that demand strict security. So, similar to what's happening in the backend, the certificate pair is registered with the authorization server, and the resource server against, from which we are requesting a resource, will confirm, you'll get a confirmation from the authorization server that this is in fact the intended requester. Here is an example of the earlier backend approach to protecting against replay attacks. This is the requesting side here. We have extracted the client certificate. We are computing a SHA-256 thumbprint, and we are inserting it into the claims of the JWT. So, once we retrieve our token, it will actually contain this thumbprint. And this is an example of what's happening at the receiving side. They will receive the requester's JWT, they will extract this claim, and again, because we have established mTLS, mutual TLS, meaning both the requester, so both the client and the server have shared their certificates, the receiver is able to extract the requester's thumbprint and compare it to the one which is in the claims. If it does not match, it's an invalid thumbprint, and this token is rejected. So, remind you again of the original scenario here. We have a high-level employee, maybe C-level, their token is intercepted. They will be protected from attack against a different resource here, which might contain very sensitive data, because the thumbprint will not match. And again, we're talking about the environment of a large corporation with many, many employees of varying technical abilities. And the third pillar, which is going beyond static roles with policy as code, everybody who has used Spring Security, which I assume is everybody in this room, has used the approach here on the legacy side using annotations, where we check for certain attributes that we can get from an LDAP, for example, like the user has a specific role, and we can reject access to a resource based on, or endpoint, if that role is not present. The new approach here is using policy as code. The example implementation here is the open policy agent. how does it work? We have multiple components here. We have a sidecar, which will pull the actual relevant policy files from a Git repository, for example, where we store them. And our application will make a call to the sidecar to verify that that particular user should have access to an endpoint. What does this do for us? We have access to contextual and attribute-based access control. So instead of just checking if a user has a specific role, OPA evaluates policies at runtime using dynamic signals, such as user attributes, workload identity, time, location, and other risk signals. Another would be decoupled policy as code. Security authorization rules are written as code. The extension used here is .rego, and it is completely decoupled from your underlying application pods. This separation allows security teams to independently update and deploy authorization rules in real time without requiring a full deployment of the Spring Boot application. OPA is, as stated, typically deployed as a sidecar. It runs alongside the JVM. Through policies, can also be embedded directly if you use, for example, something like WebAssembly to compile. While policy decisions are centralized in OPA, they can be enforced everywhere across your infrastructure, including inside Spring Security filters at the application controller method level and within API gateways like Spring Cloud Gateway. As we store our policies in the repository, we can run a standard CI/CD pipeline on every change, ensuring that it is correct, and we could also add additional constraints. Maybe some changes should never be made without higher level authorization, for example. Observability and auditing. So in Zero Trust architecture, deep visibility is a fundamental requirement. To achieve this in your Spring applications, you must capture rich audit logs for compliance and surface policy decision telemetry directly to your observability pipelines. This means we want to be able to trace every decision that was made based on the OPA code. Just a moment, my mouth is getting a little dry. So to continue, integrating these policy evaluations, integrating these policy evaluations into your observability setup is a critical step towards a secure by default posture. This telemetry will allow your site reliability engineering experts and security teams to build highly accurate service level objectives and alerts. Based on the architectural dashboards, key metrics, and telemetry, your monitor should include things like authorization denials per second to track how often requests are being blocked by your policies, mTLS handshake failures to monitor when services fail to mutually authenticate with one another, and policy evaluation latency to measure how long in milliseconds it takes for your runtime policy engines to make access decisions so you can ensure performance isn't degrading due to security. Furthermore, observability is essential for safely testing new security rules using Canary policies. When introducing a new restrictive authorization policy, you can deploy it in a non-blocking, log-only mode. This evaluates the new rule against live production traffic and fires a Canary alert to your observability pipeline if a violation occurs, but it still allows the application access to proceed. This gives you the data you need to validate the policy's behavior safely before you flip the switch to enforcement mode, like a dry run. Ultimately, whenever a dynamic policy change takes effect in the environment, its impact should be immediately visible with these outlaw consequences. I'm sorry, I'm getting the impression that the mic is turning on and off. Maybe it's low battery? No? Okay. Maybe it's people having found the Bluetooth? Who knows? Okay, so here is a checklist for your system and your Spring applications so they can be secure by default. Make sure you're using the latest Spring Authorization server. You, stop using static API keys. Use the SPIFFE SPIRE dynamic SVIDs. Implement certificate-bound access tokens, so RFC 8705. Decouple authorization logic using OPA, policy as code. And finally, integrate policy evaluations into CI/CD and observability, meaning both static checks in the pipelines and Canary or dry runs to see how the policy actually behaves in production. I should note that it's possible to accomplish this through other tools, and in fact, many corporations have written their own variations of these tools. But you should take a look at the underlying RFCs because they are what is valuable here. They define the security architecture. Thank you very much for listening. It's great to see such a big crowd here. This presentation was less focused on actual code, more on concepts. I do have a GitHub repository I have prepared, which is using Docker Compose to demo these concepts. I will make this URL available as soon as I get off the podium using the application, I'm not sure I can pronounce it correctly, WOA, so you can check it out. There might be issues with it. I'm open to fixing them. Please file an issue if you feel like it. The application will raise all of the components mentioned here, and you'll get a front end basically displaying each concept and kind of showing you how it works. So for educational purposes, you can see mTLS certificate rotation, you can see OPA, you can see DPOP, for example, and of course the Spring Auth server, you get a nice login page and you grant permissions like you would, for instance, in a Google social sign-on or in similar situations. So yeah, I'm going to share that after I end the presentation. Are there any questions? If yes, we have a little time, more than a little, to go through your questions. Yes, decoupling means policy changes, security policy changes are separate from business logic changes and other changes in the Spring application. So yes, the sidecar will have to pull another version from the repository and it will reboot, but the Spring application will continue to work. So they make changes at their own tempos. And as for the CI/CD and the difficulty of making a change to policy, I will again refer back to what is the context. The context is a multinational corporation that is geographically distributed. Policy changes should be subject to scrutiny. They should be a little difficult to change. You will be affecting the lives of thousands of people. You're welcome. Any more questions? Oh yes, okay, that's a good question. So, actually, no, we don't use Spring at Revolut. I've used Spring through all of my career besides at Revolut, which I have worked for the last year and a half. But we actually do follow most of the advice I have shown you here. They just implement their own tools to do it. But they follow the architectural guidelines, they follow the RFCs. So far, I don't know, have you heard anything in the news? You're welcome. Any more questions? In that case, I guess we'll close the presentation. Again, thank you all for attending. It was a great pleasure to present here. Very nice. I hope to be able to do it again someday.